Hi, my name is Jason Clark here at South Dakota State University, and today we're going to be talking about our nitrogen recommendations. A lot of times I get questions about the states around us, such as North Dakota, Minnesota, Wisconsin, Iowa, Nebraska, and other people who use a different nitrogen recommendation system than we do called the maximum return to nitrogen. So that's what we're going to be talking about today, and then comparing it against our current system to see which is better or how close they are. And I think you'll be surprised that they're pretty evenly matched. So if we look at the equation behind us, we can see this is our typical nitrogen recommendation system for South Dakota with one minor change. And that minor change is here in that coefficient or that multiplier. So that multiplier went from 1.2 to 1.0, but still we're looking at that yield goal times the multiplier, subtracting our soil test N, taking care of our legume credit when it's needed, and also our no-till debit if we're within about 5 or 6 years of entering new no-till, changing from tillage to no-till. The biggest question about this is what about economics? Fertilizer prices have gone sky high in the last several years, and how do we account for that? Am I still applying too much nitrogen here? So it's really going to focus on is what about economics? And I'll show you why economics are so important in this next slide here. So in this slide we have a typical response curve. We have on our y-axis over here our corn yield, our excess, our nitrogen fertilizer rate, and this is a field in the farmer's field in Salem, South Dakota. And if we look at the response across these different nitrogen rates, we see that we increase, but we start going down until we hit a plateau. And that plateau comes about 120 pounds of N, and we get about 225 bushels of corn. Now, if we were to look at that zero rate of nitrogen right here, we get about 120 bushels of corn without adding any nitrogen. If we add about 40 more pounds of nitrogen to there, we're getting an increase of about 54 bushels of corn for that added 40 pounds of nitrogen. If we add another 40 pounds of nitrogen on there, we're only getting about 34 bushels per acre. If we add that final 40 pounds of nitrogen on there, so we get our optimal, we only add 14 bushels per acre. So we start off by getting 34 bushels per acre, or going from an increase of 54 to 34, up to about 14 bushels there. So you can see as we add more nitrogen, we're getting less in return. So that kind of shows us where economics are in there. So we're getting less of a return by keeping adding more, but we're still getting a return. But as long as we're paying for that increase, we're doing well. So what maximum return to nitrogen does, we're looking at yield over here, but we're also looking at nitrogen rate and nitrogen cost, as well as costs of our yield. So we looked at multipliers before, looking at that coefficient or multiplier of 1.0 pounds of nitrogen per bushel of corn. Instead of looking at amount of urea or nitrogen fertilizer to corn bushel yield, now we're looking at price. We're going to look at the price of the urea, we're going to look at the price of the corn or whatever nitrogen fertilizer we have. So traditionally, we're looking at 40-cent nitrogen, $4 corn. And if we look at that, and what that equals is about 0.1 bushels of corn per pound of N, which means I need to increase by 0.1 bushels of corn for every pound of N to pay for it. But this is our long-term average. Today's average is a little different. We're at around $1.03 nitrogen, $6.95 corn. So if we do the math there, we're about 0.15 bushels of corn we need to increase for every pound of N. So you can see just from that, we went from 0.0110 bushels to 0.15 bushels. So we need to get more corn back per pound of N we're putting on now than we used to. So to kind of clarify this a little bit more, we're going to talk about two different definitions here. We're going to talk about agronomic and our economic optimal N rate. So our agronomic is what we think is that nitrogen rate max yield. Economic is a little different. As you can see here, you go ahead and read it. I'll explain a little bit here. It's a point where that increase in yield pays for it with the increase in nitrogen that we put. So we want that nitrogen we put on to be paid for in that yield increase. So once that stops being paid for, that's our economic optimal N rate. And I'll show you an example right here at a site in Brookings, South Dakota this past year in 2022. So we look at our corn yield on our y-axis, our nitrogen rate on our x-axis. We can see here the increases until we hit our optimal yield or our max yield, which was about 85 pounds of N. We got 224 bushels of corn. So behind that, what we're really looking at here is our economic. It's a little bit lower, so when that nitrogen stopped paying for itself, it was around 76 pounds of N, and we got a yield of 223. So only 1 bushel difference, but we save about 20 or so pounds of N, which over a field can add up to quite a bit of nitrogen there in savings. But this isn't always true in every field. We look at a different field, very close to this, except for in another part in Brookings, South Dakota. This field right here, we see the response curve is a little different. It increases a little bit slower than before. So our agronomic is over here at 206 pounds of N, while our economic is over here at 148 pounds of N. So that's a rounded change, about 50 pounds of N per acre. So that's a really big difference. So if we want to look at this example here, we're going to stick with this Brookings field, here, and we're going to change it a little bit. So instead of looking at corn yield on our y-axis over here, we're actually going to be looking at dollars per acre. And here we're still looking at nitrogen rate. We're going to have three lines we're going to show up. This first one is nitrogen cost. So as you can imagine, as you apply more nitrogen, just like this blue line goes up, our cost of nitrogen is going to go up. Now if we look at our yield response for how much profit we get from our yield, it goes like this. So we see that sharp increase, but eventually it's going to flatten out like it did. And then we're going to get our net return, which is that green line, which is our profit, subtracted from that blue line, which is our cost. And that shape looks about like this. So as we increase in nitrogen rate, we increase in profit until we hit an optimal, which is right here. And we go plus or minus $1 of that optimal, we see this range right here, about 70 to 80 pounds of nitrogen in this field. But if we keep increasing to 90, 120, 150 pounds of N, we're seeing how much we're decreasing. We can actually decrease in profit by about $40 per acre by over-applying nitrogen. Now, this maximum return nitrogen doesn't work by one field by itself. It can over time, so you can get this. It takes about 5 or 10 years in your fields to do it, but it can be good so you can see what that range of nitrogen requirements is for your field. But if we do this across all of South Dakota, we get an economic optimal nitrogen rate in today's corn prices and nitrogen prices of 103 pounds per acre. If we divide that by eastern and central South Dakota, we get 105 pounds of nitrogen in the east and 81 in the central part of the state. So how accurate is that? So we take 2018 to 2021 data and we subtract it from the actual amount needed. We're going to look at this graph right here. So closer to zero is better. Positive numbers are overestimations of nitrogen. Negative numbers are underestimations. So if we just use that South Dakota recommendation, we see an overestimation of around 40 to 60 pounds per acre. If we use east and central South Dakota, we want that line to get closer to zero. We can see over here in these central sites, normally that blue line is closer than that red line, which shows us the central part of the state definitely benefits from dividing the state, whereas the eastern part doesn't show us as much benefit, but it is showing a similar accuracy whether we divide it or not. We definitely need to do that in the central part of the state. So overall, when we look at this, using the whole South Dakota maximum return nitrogen, we're plus or minus 40 pounds of N. East, we're plus or minus 37. Central, plus or minus 50. So still working on that accuracy there. Now, if we want to add in 2022 data, how does that affect this recommendation? So if we go from 103 pounds to 97 pounds across the state, 81 down to 60 in the central part of the state, which actually shows us that our rate probably needs to be a little bit lower as we see some of these dry years continuing, and the eastern went down just a little bit from 105 to 102, so not a big change in eastern South Dakota. If we want to look at the accuracy here, and the accuracy again, the red line is across all of South Dakota, the blue line is using the east versus central. So you can see again in the central part of the state, we normally are seeing areas where we're using that improving by dividing up the state, whereas the eastern part over here, not as much. We want to look at the accuracy overall, plus or minus 42, plus or minus 37 in the east, and plus or minus 38 in the central, which is better than plus or minus 50 when we didn't have that 2022 data in there. So you can see maximum return to nitrogen gets better as we get more and more data in there as what we're working on right now. So if we're trying to predict 2022 from 18 to 21 data, we see that we're plus or minus 40 pounds of N per acre. Improve some by dividing out by east and central. We're predicting all the sites across South Dakota with 2018 to 2022 data. We're plus or minus 42, so pretty similar there. Plus or minus 37 or plus or minus 38 for the central part of the state. So the MRTN is getting better as we're getting more data into it. Now if we want to compare that to our current yield goal-based system, which is using a 1.0 multiplier now, not this 1.2 noted here. So we look at that information, we're about plus 13 on average, or plus or minus 45 from 0. Now if we look at predicting 2022, we're plus or minus 40, which is a little better than what we're seeing here, but plus or minus 37 or plus or minus 50 there. 2018 to 2022, plus or minus 42, plus or minus 37, 38. So you can see using this MRTN approach, we are getting better at getting a little bit closer than maybe this 1.0 coefficient. However, we're still tending to overestimate a lot of sites using this MRTN fashion. We're not overestimating as many sites with this 1.0 yield goal approach, which is why we're sticking with it for now. However, we'll see in the future if getting more sites and more information and more soils information in this equation can help us further improve our recommendation. And as always, thank you for your time, and please follow us on social media here on YouTube to get more of these updates, and also any in-person extension videos and other things are on the extension website. Thank you.